Today, we're diving into a really elegant piece of physics that lets us figure out the secrets of the universe just by looking at its color. It's called Wiene's Law, and believe me, it's the key to understanding everything from a star billions of miles away to the burner on your own stove.
So let's start with a question that sounds, well, kind of impossible, right? How in the world do you take the temperature of something that's trillions of miles away? You can't just send a probe with a thermometer. So how do astronomers know that one star is a blistering 20,000 degrees, while another one is a much cooler 3,000?
Well, the answer isn't some super complex, futuristic device. It's actually right there, hiding in plain sight, in the light that travels all that way to reach our eyes and our telescopes. The secret to a star's temperature, it's literally written in its color. And you've definitely seen this in action, probably without even thinking about it. Picture an electric stove. When you turn it on, it starts to glow this dull, deep red. Crank up the heat, and that glow gets brighter, turning to orange, and then to a brilliant yellow-white. That simple, everyday observation is the key to this whole thing. See, that relationship between heat and the color of the glow, that's not a coincidence. It's all governed by a fundamental law of physics. So let's make it official and introduce the hero of our story, Wiene's displacement law. It's the principle that so beautifully connects heat directly to color. Okay, that might sound a little complicated, but the most important part is that phrase, inversely proportional. It's just a fancy way of saying that as one thing goes up, the other thing goes down. So, as an object's temperature gets hotter, the peak wavelength of the light it gives off actually gets shorter. And this is the elegant little formula that describes it all. That symbol, lambda, stands for the peak wavelength. You can think of that as the most intense color the object is glowing. T is just its temperature, and B is a really special number called Wiene's constant, which is what links the two together perfectly. And here's the real insight, the main takeaway. Red light has a long wavelength, and blue light has a very short one. So when Wiene's law tells us that a hotter object has a shorter peak wavelength, it means its color is shifting away from red and moving towards blue. It's why things glow red first, then orange, then yellow, and eventually, if they get hot enough, a searing blue-white. Put simply, hotter means blue. So what about that letter B in the formula? What's its deal? Well, that constant is what turns this from just a cool idea into a precision scientific tool. Let's take a closer look at this so-called magic constant. This is it, Wiene's displacement constant. And what's so amazing about this number is that it's a universal conversion factor. It doesn't matter if you're looking at a star in another galaxy or molten steel in a factory here on Earth. This constant is the bridge that connects wavelength to temperature everywhere and for everything. Its very existence tells us that there's this fundamental, unchanging rule woven right into the fabric of the universe. Now, in physics, there's usually more than one way to look at the same phenomenon. So far, we've been talking about wavelength, but you can also look at this whole relationship through the lens of frequency. So on the left, you've got the formula we've been using, which focuses on the peak color. And on the right, there's a version for frequency, which is really about the peak energy. They look a little different, but don't get too hung up on the math. They're just two different lenses for looking at the exact same physical reality, two ways of telling the same story. Okay, so this is obviously fantastic for astronomers, but why should the rest of us care? Well, it turns out this law has applications that are incredibly down to earth. I mean, of course, it's absolutely crucial for measuring stars and figuring out the temperature of distant planets. But it's also used right here on Earth to monitor the crazy hot temperatures of molten metal in a foundry. Every thermal imaging camera, every one of those non-contact thermometers that you see everywhere, they all work because of this exact principle. Even the simple glow of an old incandescent light bulb's filament is a perfect example of Wiene's law in action. So really, what this all boils down to is that Wiene's law is basically a universal, non-contact thermometer. It gives us this incredible power to measure how hot something is from a safe distance. And it doesn't matter if that distance is a few feet from a furnace or quadrillions of miles across the cosmos. Which brings us to one last really amazing thought. The law says that anything with a temperature above absolute zero emits light. That includes stars, stovetops, and yes, you. Right now, your body is glowing, giving off light in the infrared part of the spectrum, which our eyes can't see. But it's there. You're glowing. And thanks to Wiene's law, we know exactly what color that glow is. How cool is that?